I'm Renee Williams.
And I'm Billy Thomas.
And welcome to another edition of From the Woods Today.
I'm glad to have you all with us today. Renee Williams is on assignment today, so she won't be with us. I do have Dr. Ellen Crocker as a backup. She's here to help out. She's going to be helping co-host today's show, and I'm glad to have her with us. Dr. Crocker.
Hello, how's it going?
Happy New Year. I
Year.
know, it's great. Hopefully you had a nice break with the family.
Oh, I did, but also excited to get back to things here.
Yes.
And yeah, we got some great presenters today for our first show of 2024.
I know, I'm really excited. We have Anna Weicker, who is a new member of our team, and she was with us in December, and she's going to be talking about how to be a better naturalist. It's something I think we can all appreciate and learn from. We're glad to have Anna on doing that segment for us. We also have Mr. Michael Ammerman. He's going to be talking about the GIS and a kind of a new element and how we can use that GIS in some of our management activities. So I'm excited to have both of those guests on with us. Glad to have you, Dr. Crocker, co-hosting.
Happy to be here. We miss Renee, but happy to be here.
I know. Renee will be back with us next week after she wraps up her assignment, but we hope everybody's 2024 is off to a great start, and we really appreciate you all taking a few minutes to be with us today on this episode. If you do have questions for our presenters, you can use the chat function, or if you end up watching on YouTube, you can hit us up via email at forestry.extension@uky.edu, and we can respond to you that way. But I'm delighted to have you with us. Dr. Crocker, I'm ready to get this show started.
Let's do it.
All right. I think we're going to bring up Anna Weicker first. Anna's going to be talking to us about being a better naturalist. Welcome, Anna. Happy New Year.
Hey, Happy New Year, you all.
And what a good topic for you as the Master Naturalist Outreach Coordinator to tell people about being a better naturalist, whether they're a master naturalist or not.
So true. And I did resist the urge to have my entire presentation just become a Kentucky Master Naturalist. And then that's the presentation. That's the end of my discussion. But we're going to go a little bit more in depth. We're gonna branch out a little bit, so to speak, for sure.
Awesome.
But yes, I'm very excited. I'm excited to be here.
All right, let's get her going.
All right. So just like Billy mentioned, I'm going to be talking about becoming a better naturalist in 2024, some sort of nature related goals and resolutions that you can make for yourself this year to get outside more, to get engaged a little bit more with the environment. I am the Kentucky Master Naturalist Outreach Coordinator for the Master Naturalist program, and I'm new to the team, and I'm just really excited to be here. I'm excited to be brought on the show and be able to talk to you all first thing in January of 2024. So let's just go ahead and get into it. I am a big New Year's resolution person. I am the most organized and healthy person for about the first 12 to 13 days of the new year. And then, we sort of slide after that. But I've really focused on nature and, improving my skills as a naturalist in this coming year. So, hopefully that'll motivate me to keep to my goals better. I'm pretty excited about it. So that all being said, let's just jump right into it. Let's see. So first up, this one is a big one for me. It's something that I'm very passionate about. Participate in science, and you can do that with your phone. You can do it easily and inexpensively with a citizen science project. There's ones that are going to fit in all budgets, in all schedules, locations, time that you have to invest in it. There's lots of different options to get involved in a citizen science project and help contribute to nature, as well as get, a little bit more engaged with the environment right outside your door. So iNaturalist and eBird are a couple big ones. I'm going to get into those a little bit more in a second here. So we'll go ahead and breeze right along to the Great Backyard Bird Count. This is one that is just going on. Wintertime, short little window of time. It's counting birds at the feeder, outside your window, in your backyard, local park, whatever you may have. It's a great one to get involved with. It helps scientists to gauge the population changes, expansion, abundance, whatever it might be, of common backyard birds that are often our first indicators of change in the environment. So Great Backyard Bird Count and Project Feeder Watch, very similar. Great ones to get kids engaged with. Both of them are hosted or co-hosted by the Cornell Lab of Ornithology, and they're great ones to hop onto if you want to stay inside with your hot chocolate, with your coffee, whatever your poison is, and just look out the window and count some birds for science. Those ones you can sign up online, search them online. Very easy. You don't need to be the most knowledgeable bird person in the world. They're just really great ways to, kind of get through the winter months, beat the winter blues, and contribute to science at the same time. Monarch Watch and Project Budburst are another couple great ones. Monarch Watch, of course, focuses on monarch butterflies. And that is, if you've never done it before, they host or facilitate the program where you tag monarch butterflies and they track their migration to Mexico and then back to the eastern United States every year. So if you want to get hands-on with some butterflies and you have a little bit of, prep time to sort of research and, feel it out before summertime, before the monarchs start showing up, Monarch Watch might be for you if you are a summer weather butterfly type of citizen scientist. Project Budburst is an app-based one. It's a citizen science project that focuses on things like the seasonal changes. So like when flowers start blooming, when trees start leafing out, when birds migrate, which are so important for scientists to keep track of, changes in climate, changes that are taking place over large areas in long lengths of time. But if you are one of those people who, thinks to yourself, hey, I never noticed that like my maple tree was leafing out in February before. Guess what? Get onto Project Budburst and share that information with the scientific community. Very easy, very user friendly, and you are helping contribute to data collection that, contributes to our collective scientific knowledge, right? Firefly Watch, another great summertime one, another great excuse to get outside in those summer evenings and count some fireflies. And that one, similarly to Monarch Watch, is one that you'll be doing a little research on now, but not really engaging in until later on in the year when these insects start showing up, right? So I'm going to hop back to eBird and iNaturalist because those are two of the easiest, user-friendly, all year long, all time of day or night citizen science projects that you can engage with. Both of them are apps, both of them are free. And the idea behind them is that you just document whatever you're seeing, right? So you can see I've just pulled up my little iNaturalist dashboard here. I was looking at some winter creeper. I was looking at some American holly, a box turtle, some little moth guy. And you upload those all to iNaturalist, snap a picture, include a little bit of information about where you saw it and what it is. And even if you don't know exactly what it is, the iNaturalist community is going to be hopping on those comments and helping you identify it. So this is a great way to just contribute, again, to that huge database of scientific information that anyone can access, but also for you to keep track of, your own observations and your own learning and knowledge of the natural world. And this is one that I'm going to be working on this year, especially. I have a goal of adding 300 new observations to iNaturalist this year. So I'm hoping that I purposefully blocked my username on this so that no one would be able to go back and check and see if I met my goal. I'm just kidding. But this is a goal that I'm focused on this year for sure. So super easy, again, straightforward, free, great to get kids engaged, great to get you out and about at your local park or on your own property, documenting what's out there and learning about it. Next up, seek out some guided events, get outside your comfort zone. If you are anywhere close to a local park, state park, privately owned nature center, sanctuary, any type of land where you can go and, be out in nature. A lot of the times if they're staffed, they offer programming particular to that location. So many times those are free or inexpensive, educational. They're a great way to get out and learn something from a guide that's very knowledgeable about that specific area or subject. You can meet people who care about the same things. Guess what? You are not the only person who likes to stare at trees. You can go out and meet other people that like to stare at trees on a tree staring program. You can also be a back of the group introvert listen, nature people, sometimes they just like to be out in nature and not associate with anyone else. That's cool. You can go on a guided hike, but also, kind of maintain your introvert status if that's your goal. And it's also a great way to experience new aspects of a place that you might think you're very familiar with. Maybe you go hiking at your local park all the time, but one day you decide you're going to go out on a night hike and you're going to go search for owls on a guided tour. And that gives you a really cool way of experiencing that area in a way that maybe you've never seen before. So, get out there, engage with something new, engage somewhere new, get out on a guided hike. It's always worth it. It's always fun. You always learn something. Um, Listen, if you're like me, if you're like most of us, you probably like internally or externally cry a little bit after you are done checking out at the grocery store, right? We're all trying to save money right now, and you can save money on vacation by staying in our state. We are an incredibly ecologically diverse state with amazing, like, incredible opportunities for just seeing some natural wonders that you're not going to see anywhere else. I think we take it for granted a little bit, myself included for sure, because we live here, so we're used to it. But other people drive here to see all the cool stuff we have, and it's right outside our door. So plan your vacation this year to stay in our state. Here we've got some sandhill cranes migrating through on the Mississippi Flyway in Western Kentucky. Of course, Red River Gorge is always a big one. Breaks Interstate Park on the state line in Eastern Kentucky. Gorgeous, gorgeous hiking. I think that's River Styx Spring and Mammoth Cave. But there's just so many amazing opportunities out there, whether you want to see big scale bird migrations or, you want to go hunt for spring wildflowers in the gorge. There's incredible opportunities out there to experience amazing things in nature without racking up that vacation bill. So a lot of us are, starting to think about what we want to do this year in terms of property management, whether that's your front porch planters, maybe you got the winter blues and you're already making that seed catalog list, or maybe you're thinking about doing some large scale logging, timber stand improvement, whatever it might be on your property. Think about ways that you can make your space, whatever it might be, more friendly for wildlife this year. There's lots of different ways to do that. Remove some invasive species, have a goal of getting all that honeysuckle off your property. Why not, aim for the stars? Plant natives, replace some of those species that you're removing with native species. Think of ways that you can have your front annual flower bed be native species rather than, ornamentals. Add some features, put a bluebird trail on your property, put an owl box up, put a bird bath out. Make it a little, little extra fancy real estate for the critters out there. And if you want a goal to aim towards, if you want that extra credit, you can register your space, your property, your yard, whatever it might be, through any of a number of organizations that will kind of recognize you for taking that effort. Monarch Waste Stations, of course, is a really popular one. National Wildlife Federation does the Certified Wildlife Habitat program. Work on, if you're that goal-oriented person that wants that like end result, maybe work on getting that certification. And it's also a great time of year while you're indoors, while it's cold, to look into funding and assistance that you might be able to get for larger projects. There's lots of like cost shares, grants, that kind of thing for larger habitat management projects. If you do have a piece of property, some acreage that you're looking to make improvements on. And I think the state has the Habitat Improvement Program. That's a great place to stop by, start out at, but also talk to your extension folks. And I'm willing to bet they probably have some pretty good ideas for you if you are looking to do some habitat work in 2024. Last up, get out there and get into a competition with yourself or someone else. If you are a bird person, you know that bird people are kind of weird. And as a bird person, I feel like it's okay for me to say that. We love to chase things. We love to count things. We love, getting competitive in the birding world, in the bird watching world. You might have heard of a big year before, which is where you're going out and you're trying to count however many species you can see in one year. And that can kind of be in a geographic area. So as many bird species as you can see in your county, or as many bird species as you can see on this planet. Or you can just make it a free-for-all and do, however many bird species anywhere. But think outside that. Think outside, that taxonomic group. Maybe you want to see every tree that's known to grow in the state of Kentucky. Maybe you're going to go out and you're going to see as many spring wildflower species as you can. Find some sort of fun goal and set that goal for yourself. And you know what? If you don't meet it, then that's okay, because you got outside and you saw some really cool stuff. And next year you can come back around and you can compete against your 2024 self, see if you can see more species, see, whatever it might be, depending on your interests and how you set the rules for yourself. But it is a really fun way to sort of enter that competitive aspect into your naturalisting in 2024. So that really does wrap it up this time. We're not leaving in the middle of the slide to wrap it up this time. But yes, I would love to hear if you all have, come up with anything that you are going to focus on, any goals that you have related to your naturalisting and your naturing in 2024. I'd love to hear them. And other than that, we are pretty much wrapped up if anyone has any questions or anything to share.
Thank you, Anna. I appreciate that. Yeah, well, I will offer a comment. You had mentioned working with Fish and Wildlife, and we do have the Kentucky Department of Fish and Wildlife Resources here, and they do have biologists that are available to come out and meet with landowners and help them develop habitat. And I also remind folks we have foresters with the Kentucky Division of Forestry who are available to come out and meet with you and develop a management plan for your property, whether it is for, to see birds or whether it's for timber or other reasons. They will help you manage that as well. So if you are a landowner out there in the state, there are resources available. And I think you bring up a really good point. Right now, we can do a lot of our planning and getting ready for things, while the weather maybe is not as nice.
Yep. This is not winter, it's seed catalog season.
Yeah, there you go.
So be thinking about what you want that land to look like, what you want that property to look like. And like you said, Billy, it's just amazing how many resources are out there. Don't forget that you don't have to do this by yourself. You can get some folks on your property, more than likely for free, to help you out with planning this stuff. So yes,
yeah,
absolutely.
I totally agree. Take advantage of those opportunities, folks, and better habitat as well. All right. Well, Anna, I'm not seeing any questions coming up, but hopefully you can stick around. We might get some that pop up during Michael's or after. Sometimes it takes folks a few minutes to come up with their questions, but thank you very much for your segment. Do appreciate it.
Absolutely, for sure.
Excellent. All right. So Michael, I think we're really ready for you this time.
Okay, that's perfect. Perfect. Happy to be here. Happy to be a part of the crew, and I always love being on here because I get to kind of ramble on about my kind of hobby with GIS and how I like to use it and things like that. So I appreciate you all letting me be on here and share some of this stuff.
And today you're taking us back to school. So Professor Michael's lesson on GIS, you're going to give people some math.
Yeah, there's going to be a little bit of math, a little bit of physics, a little bit of some plant physiology. Now, quick disclaimer. I do not claim to be a plant physiologist or a physicist. So what I'm going to give you some of this information is a pretty rudimentary education, because that's about the max education I have on it. So
okay, I think so. Today, you're going to be teaching people about some technology that may seem really overwhelming and kind of challenging, but there's a lot of potential to impact kind of what you're doing in your woods and your management. And maybe it's not as insurmountable as you might think. It might look really challenging from the outside, but you're going to give people the behind the scenes of how it works. A sneak peek.
That's exactly what I'm planning on doing. I'm gonna try to make it as simple as I can. And I think that this is really, it's kind of just follow steps, and you can see how you can do this in your own management and how you can kind of see what you're getting in your area, right?
All right.
So
looking forward to it, Michael.
Okay, perfect. So first I want to talk about a GIS aspect known as NDVI. And I'm also kind of wanting to give a grasp on, I'm going to leave you all with this question to start with. And it's, why are plants green? Now, I know that may sound like because they look green, right? Or because I see them as green. But I want to tell you all exactly why you see them as green, right? So we're gonna kind of dive into the GIS applications that come with this. Okay, so first we want to talk about, what is light? Well, everybody would say, well, that's when I turn on my flashlight, I turn on a light switch, and now I can see. And yes, that is correct. But light is actually, what you're seeing is a form of electromagnetic radiation. So essentially what happens with light is that it acts as a particle and a wave through a particle element known as a photon. And we have things called electrons and they oscillate based on these waves. So as you can see here, as we have this wave right here, this is what's known as an oscillation. So what that means is using that is how we measure our wavelength and the oscillation, the amplitude, to understand how these bands are interacting and what they're forming. So essentially what happens to create this is, light is energy, essentially. So what happens is electrons become excited and then release photons. And what happens with electrons when they become excited through energy, they go to what's known as their outer state, and then they have to release some form of energy to get back into their what's known as their normal state, essentially. And so when they return to this normal state, they release that energy as a photon. And these different photons have different wavelengths that create different types of radiation, which we then see as light. So what happens with that is, humans can really only see in 3 colors of wavelength. And that's what's known as visible light. And this visible light is made up of red, green, and blue light. So I actually only see red, green, and blue light. But how we interpret colors in the physical aspect of the world is when we have that reflection, we see a combination of the light intensities that we're getting, and that our brain, through our conal cells within our eyes and our pupil, then translates that into an image with the colors as we see them. It's actually kind of also how your LCD or your LED TV works, is it's made up of pixels, but inside those pixels, there's known as 3 micropixels that are made up of red, green, and blue. And when they are in tune to different frequencies or different light intensities, they form the colors that we see coming from them. And that's a little, you can look some of that up more. It's called the RGB color scheme, and you can see how that works and how those different intensities form different colors. So here we can see we have types of electromagnetic radiation. And I just kind of want to leave you all with this kind of idea. So as the wavelengths are shorter, we get what's known as gamma rays, and they're moving quicker, but they don't have as much energy. So they're quick moving particles, and they move fast. So that's why we get gamma ray radiation. So what happens is, and then people will ask, okay, I thought radiation was bad. And yes, some form of radiation potentially is harmful, because where these particles are moving so fast and they're able to penetrate deeper than other forms of light within that wavelength spectrum, within that spectrum, these can actually blast through your cells into your nucleus and into your DNA, thus breaking it. And when that happens, you can get issues with repairing the DNA, since DNA is the building block of humans. You get things that can cause cancer or other health related issues within humans, because it's essentially blasting through your DNA cells and kind of mismatching some of those building blocks within the nucleotide, right? So that's how you also get X-rays, right? So X-rays, they're shorter bands, and you have to worry about them. So that's why you wear the lead chest protector and things like that when you get an X-ray at the doctor. But they go deeper, and they can penetrate past your skin and then reflect an image back that shows your bones. So that's how we're able to see our bones. Ultraviolet light is what you typically see from the sun that you get. And obviously we have our visible light here. Now infrared, I'm going to get back to that, because infrared is also really important when it comes to what we're going to talk about with plants. And then your radio wave frequencies that you see is actually just a form of light. We can't see it, but then that form of light is interpreted through your antennas and your radios or your TV or things like that into binary code, ones and zeros, that then create the images and the sounds that we know that we're familiar with. So as you think about it, AM radio and visible light we see is actually kind of on the same as all forms of light, just different wavelengths. And so going to the next one. So here we're going to talk a little bit more about infrared, but I kind of want to get to how infrared was discovered. So what happens is with infrared light through a prism, as you see here, we can see where the wavelengths hit the prism, and where there are different lengths, we can see the different colors coming out of that. So as you can see, as these wavelengths connect, we see different forms of colors, which is also known as colors of the rainbow, right? You have Roy G. Biv, right? So you can see how those come out there, right? And then, so what happened essentially was there was a British physicist, Sir Frederick Herschel, and what he did was he passed light through a glass prism. And what he did was he saw these bands, he saw the visible light bands, and he took a thermometer and put a thermometer on each band so he could measure the temperature and the energy coming from them. But so he had a fourth thermometer that he put on the edge of those other three thermometers as a control. Then after he came back, several minutes later from his experiment, he saw on the end that the temperature of the thermometer that was on the outside of the color spectrum was actually hotter than the ones that he had it focused on. And then how he noticed that was he said, well, it's not room temperature, because he looked up on the wall and he had a thermostat on the wall that showed that room temperature was actually below the red band. So what's funny about that is then he could take his hand and he could feel the energy from that infrared band. He just couldn't see it. So he had to theorize that, hey, there has to be more wavelengths of this light than what we can actually see. And this is back during the 1800s, before we had the technology now that we can see that can convert and see things such as infrared light or radio waves, and before microwave and things like that. So I don't know why I skipped that last slide, but let's go here and see this real quick. So I want to kind of talk about normalized difference vegetation index, and I'm going to show you all how kind of this works. So essentially what this is I want to kind of talk first about, so plants use photosynthesis to make food. So essentially what that is it takes photosynthetically active radiation, also known as light, right? But it's the photons of light that plants can absorb, right? Which is red, blue, and infrared light, not green light, because we see the green light as a reflection because the plants through chlorophyll aren't taking that pigment up. So pigment in plant leaves, chlorophyll strongly absorbs visible light from 400 to 700 nanometers for use in photosynthesis. Now, I'm not a plant physiologist, but from what I understand in reading textbooks and reading texts with this, is that some botanists and biologists think that the reason why plants don't absorb the green color light has something to do with intensity and the availability of energy. So they use the green band because it's in the middle. They refuse the green band because it's in the middle of the spectrum, and it's harder to regulate the energy input they're getting through heat. So they also have to release some of that as heat energy, right? So that's actually how when we see white. So white and black. So if you have a black object, typically in the summer, you know that it's hotter. And then a white object, in the summer, it's typically cooler than that black object sitting in the sun. Now, why is that? Well, that's because white reflects all light, which we see white as all colors of light. And then black is technically the absence of light. So it absorbs all those colors, all those visible light spectrums that we see. And then in order to release that energy that it's created, that it's accumulated through that light, it has to release into the atmosphere or into the surrounding area as heat energy. So that's why you feel the heat when you get closer by black's hotter than white. So NDVI is used to quantify vegetation greenness and is useful in understanding vegetation density and assessing changes in plant health. So essentially what that means is plants that are more green, as you can see in this diagram, near infrared, are going to reflect more infrared, which is up to 50% of that infrared light that's being sent to it. It's going to reflect that back, and then it's going to reflect less red light. But as plants become unhealthy, as you can see here in this aspect, you can see that we can see how this infrared, the absorbing infrared, start reflecting more red because they essentially are needing more of that energy. And you can see them as different. We see that mixture of different colors and not just straight green vegetation. It's also kind of been theorized as to why when plants die in the autumn, they turn different colors because they're not absorbing that same color of light anymore because it's not necessarily active, right? So you get a mix of the lights being reflected back more. And then we use this formula here. So it is we take the near infrared band and subtract it from the red infrared band, and then we divide it by the infrared band plus the red band. And what this is used to, instead of just simply subtracting one or adding one, this allows us to get a index or a range between -1 and 1. -1 obviously being dead plants or inanimate objects, and then 1 being very healthy green plants. Now I'm going to kind of show you how this works on GIS real quick, and how we can see this and how we can use this from a management aspect potentially, or how we can use it to understand kind of what's happened with our land or what we see within our land. But while I'm kind of crossed over, does anybody have any questions on some of this?
Well, I feel like I just sat through a lecture, and I know that's a lot of information to absorb. And we're talking about absorbing light and reflecting light. So I guess that's fun. But I think what's really cool is that maybe we've learned this in school and in classes, but how does that apply to these kinds of new tools that people are using? And I know we're back to your PowerPoint now, but the screen you were just showing has some imagery that might be familiar. Like you've pulled up Google Maps and like seeing some of that satellite imagery that is just more and more accessible out there. But how you can actually use some of these principles for the work you're doing in your woods. So yeah, I can see that. Looks great.
Okay, so one thing that's cool about this is, as I was talking about with the visible light we see through red, green, and blue, is we can see all this color is being reflected at us in this form. Now we don't really, in this form, we don't have a way of objectively saying, okay, this here is greener than the parts around it. And thus then this vegetation here being considered healthier, right? But to put this in an objective standpoint, so we get a value for the greenness and the healthiness of these plants and how you can potentially manage your forest or manage your woods, you see, okay, I may need to do some kind of management here because I have a lower quality of timber, a lower density of vegetation, right? Or healthy vegetation. So when we do this, we'll go ahead and we'll run. I've been running a few NDVI things today, but in here, so it's going to block on my screen 1 second. So we go into the raster calculator. We go in and click on NDVI. And since we have our bands here, we can go in and actually I need to show you all. I kind of think it's good to show you all some of these bands here. So as you can see here, we can see our band metadata. So we have 4 bands here. We have the red band, the green band, the blue band, and the infrared band, which is band 4, and the red band is band 1. So when we accumulate this, we want to run our raster function within DVI. So we want to put our visible band, which is red, which would be the first band, and then we want to put it over the 4th band. Now we also want to click the scientific output because that applies it to the formula instead of just subtracting it or adding it, which then doesn't give you that value between -1 and 1. It still gives you the kind of an index of it, but it doesn't make a normalized data, mathematical representation of it in a way between -1 and 0. So when we see this, I go, oh, okay, we have this image here. And we can literally see now that we have where the plants are greener and where we have inanimate objects here. So, right. So we're getting almost pure reflection back from these pools of water, right? So, and then here in the fields, we're also seeing that we're getting a lower amount of, we don't have very many, if any, green vegetation. But as we can see here, we can see a very intense, as it gets closer towards these higher values, closer to orange, we can see a higher intensity of, we can see kind of our intensity of woodland and forest here. So as you can see from this image, I would have thought here would have potentially been a little bit more green and a little bit more dense, but as I can see here, I now have a an objective standpoint that tells me, okay, this stand over here is more healthier than here. So maybe I should have a forest management, or I should go out there and look and see kind of what's going on in this environment that's kind of preventing maybe some of this greenness or some of this healthy vegetation. And here I can also change these bands within symbology that can show it as a green band to a red band, to where we can see now more of an actual forest representation. So we can see here we have a high intense, a very healthy green canopy here. And if anybody has any questions on this, please let me know. You can also contact me at michael.ammerman@ukwild.edu. I'd be happy to answer any questions you have, or even, sit and talk with you or meet with you and potentially and discuss some more of this and some of its implications.
Michael, there was a couple of questions. One, is it feasible to compare the differences in NDVI data from rare plant communities to the surrounding environment to identify potential unknown sites in Kentucky? And if so, is anyone doing it currently?
Hold on one second, Billy. Let me read that question so I didn't.
Okay. Yeah, it's in the chat there, and there's a couple in there.
Is it feasible to compare the differences in NDVI data from rare plant communities to the surrounding environment to identify potential unknown sites in Kentucky? If so, is anyone currently doing this? No, I don't know of anyone currently doing this. I think that it is feasible. I've had we have a brilliant professor here. His name's Dr. Young, and I worked with him a lot in undergrad, doing some of this GIS work. And we've kind of talked about some of this kind of forest health implications and some of the things potentially we can do with invasive species along that line, or some of these distinct plant communities that we can create formulas potentially that can help with this. Now, Dr. Crocker may be able to elaborate more on some of that behind the scenes than I can. But from what I understand, I don't know of anyone really doing that. But I mean, I think it's completely possible to kind of identify some of these rare plant places with some of the emissions essentially from light radiation that we see.
Oh, I would think so. And I think it would depend on, what kind of plant community you're looking for, because they would, and also the resolution needed to detect some of that. Obviously, your satellite imagery is not going to work great for detecting like one little rare plant in the understory. On the other hand, it might be a better fit for something that's going to be kind of like a canopy level thing, or something that you can detect in the winter when other things have lost their leaves. And also kind of scale. Is this something that you're going to need a drone that it's going to get kind of higher resolution image, or is that satellite image going to be enough? As Michael mentioned, one of the interesting things that Dr. Young and myself have been working on is looking at invasive plants, because some of the invasive plants in our state have really different phenology, and so that is the timing of when they do things. So if you know bush honeysuckle, you know that it loses its leaves later than our native species, and it gets them earlier. And while that's a problem because it lets bush honeysuckle photosynthesize for longer, it's also a tool in our toolbox in that if you're looking at aerial imagery, sometimes you can pick things out different times of year because everything else has its leaves off. And if you see some shrubs with their leaves on, you're like, I wonder if that could be an invasive plant that I should manage. And you can do that for some different types of things. And a really good question, just in terms of how this technology is being used with rare plant communities, I'm sure it could be used to detect different things from the plants to maybe the different features of the landscape that would support some of those plant communities. So really good points there. And then you had another question in the chat, Michael, about is this type of data available to landowners to map out their properties? So maybe walking them through the different publicly available kind of data sets.
Yes, of course. Yeah, I'm glad you actually had that question. I should have actually thought about doing that earlier. Now, yes, now you can do this in ArcMap. You can also, we talked about earlier, you can do this in QGIS. So I can, if we have a little bit of time here, don't we? Maybe
we got a few minutes.
On some of this data and how to get into QGIS.
Yeah.
So So, okay.
And
so
maybe, what do you mean by, what are some of the ways that people could start to look at this? Because I know a lot of folks are going to be familiar with like Google and Google Earth that lets you see some satellite imagery. But let's say you kind of want to take it to the next level. What might somebody do, and how might they approach that?
So here you can see that I have loaded up QGIS. But the first thing we want to do is we want to go to the internet. We want to search NAIP or NAIP, or National Area Imagery Program is what it stands for. In here we can see that we have the 2-foot state array. We'll go here and open that, put us into this box where we can download. So let's say I want to download, so you have your coordinates here. So let's just pick a random one that I want to download. So let's say I want to download this one. We'll go ahead and download it. So you can see up here in the top right corner, I'm getting my download. I want to go to QGIS, I'm going to go to layer. I'm going to add that layer we just add recent layer. I'm sorry, add raster layer. We'll come in here, hit add. So now we've added our layer to this. And we see we've got a lot of fields in here and things like that. So what we want to do now is we want to go to our analysis or processor. We'll go to toolbox, type in raster calculator. So there it is, raster calculator comes up. Now we know that we have our different bands here. So we know our red band is our 1. And then we know that our 4th band is the near infrared band. So here, the formula for this dictates that we need to subtract the near infrared band by the red band. And then you need to divide it and then add the near infrared band to the red band. And this is so we can get a value between -1 and 1. As you can read here, this is also something you could read further. But for now, I'm just going to show you how this works. So we will start off by, we'll go ahead and put some brackets there, so we just don't forget our places. And then we will do, so since we're starting with it, we'll do that, subtract our near infrared band. Subtract our near infrared band from our red band. And then we will add our near infrared band to our red band. We want to come here, we want to select a CRS. I'm going to put Kentucky State Plain. Oopsie. So now once we do that, we should be able to run this. Sorry, that's my fault. I forgot to put in a reference layer. So let's go ahead and make sure we put in our reference layer. And then we will now do that again since that's up. And we'll go -4, -1, and then +1. And we will use Kentucky State Plain as our CRS, which uses a temporary file. And when I run it, we now get our NDVI function. So we can see here that as we get closer to white, we can see that we have a higher resolution of green, right? So we can see we're getting more green in these areas. So the closer we get to white, the more green space we have here. Now, one thing that's kind of unfortunate with QGIS is it only has white to black and black to white, unlike what you get with ArcMap or ArcGIS Pro or so on, right? So, yep, that's how you do that in this version. We can see here that now we can see the green space as it gets darker, and then your lighter colors are more the fields and the less reflective green light, right? Well, actually, the less reflective near infrared light. So,
No.
Yeah. Well, thank you so much, Michael. Appreciate having you on and giving us a little window into what you and others do to kind of understand some of that information. Really appreciate it, and great potential to, I think, increase folks' management with some of that technology.
Indeed.
okay.
Yes. Thank you,
Thank
sir.
you.
Appreciate you very much. All right. Well, Dr. Crocker, we did it. We got through an episode without Renee Williams, which is
Oh, it was
an
hard.
amazing thing. I know. No, we'll be glad to have Renee back with us next week. She is on assignment today, but Dr. Crocker, thank you so much for being with us today. Certainly a big thanks to Anna Weicker teaching us how to become a better naturalist, and Michael showing us a little bit more insight into GIS and NDVI. So good stuff there. We appreciate both of our presenters, and we really thank you all for being with us today. As always, we'll be here every Wednesday at 11 o'clock, and we hope to see you all in future episodes. If you all do have anything you'd like to see in a future episode, please let us know. You know, Ellen, we use those a lot, feedback from folks. So if you all have got something you'd like to hear about or learn about related to our forests and natural resources here in Kentucky, we'd be more than happy to try to address that. So thank you all very much for being with us today.
Thank you, and Happy New Year.
Happy New Year, everyone.
From the woods today.